All right, everybody. Problem 2.46, like the previous one, it's also a projectile motion in only one dimension problem, just going straight up and down. To solve this problem, do the same thing as before. Make sure you draw it. Help yourself as much as possible so you don't make a silly mistake, which are really easy to do. All right, so in this problem, somebody goes off a coordinates or whatever that is, throws up the egg, goes up, and then comes down, and about 5 seconds after throwing the egg, this egg is 30 meters below the original point. This is at t equals 5 seconds. All right, so it's a projectile motion problem. They tell you to ignore air resistance, so you know that your acceleration in the y is negative 9.8 meters per second squared. You also know that your original y1 is called at 0 from where it started, and your y2 is negative 30 meters, since it's below the person. And of course, this goes by picking the coordinates such as the y is up. All right, in your quiz, you will have access to the kinematic equations for constant acceleration, which are the following. All right, so your first task is to recognize which equation you can use. Let's see, we have y1, we have y2, we have a time, we have the acceleration in the y, and the time. Therefore, we can use this equation right away to at least get information about what was the initial velocity. Now, you're probably thinking that in this case, the ball is going to go up first and then come back down and then go down to 30 meters. So you're wondering, well, can I actually solve this problem without knowing how high it goes first? And the answer is yes. All that information is already contained in this equation. It's a parabolic equation, so it will first go to a maximum and then come back down further. So let's solve for that V1 first. And y2 is negative 30 meters minus 0 for the y1. V1, a variable I need to find, 5 seconds, and so on. All right. This tells you that 122.5 minus 30 meters is equal to V1 times 5 seconds. Solve for V1 and you get 18.5 meters per second. All right, pause the video. You need to work on the algebra there. And of course, it should be a positive number since it should have been thrown straight up. Right. The other information we can find is what is the height of that maximum throw. And now that we have this V1, it will be even easier. All right, so to solve for that, I know that the V2 at the top is 0. It takes me one of these. I have the V1 that I just solved in the previous problem. I know the acceleration in the y, and now I need to find this new t, which is the time to go all the way to the top. So I get the 0 minus 18.5 meters per second is equal to negative 9.8 meters per second squared times the t to the top. Let's call it t top. And I get the t to the top is equal to 1.89 seconds. Now that I have that time, I can also find the distance from where it was thrown to the maximum height. So this new y2 minus 0 is then going to be equal to 18.5 meters per second. That's the time to the top, 1.9 seconds, plus negative 9.8 meters per second squared times 5 seconds squared over 2. And get that y2 is equal to 17.5 meters. You probably recognize that there's more than one way to do this problem. I could have found that maximum height without ever having to find the time if I would have used this equation. I know this would have been 0. I know this would be 18.5 squared. I would have known the a, and I would have found that y2 minus y1. All right, the next question was, what is the magnitude of velocity at the highest point? We already said that was 0. What are the magnitude and direction of acceleration at the highest point? You know that at the highest point and anywhere in its path, there's only one force, which is the weight, so acceleration should be negative 9.8 meters per second squared. And next, I want you to sketch the acceleration, the velocity, and the position versus time. So you know that the acceleration is negative you know that the velocity should then be a straight line with a negative slope. And since we started with a velocity that was positive, in this case, it will start at some positive value of the velocity, at some point in return, at some point have a velocity of 0 because it starts returning, and down it goes. And then finally, for the position, I know that originally it did not have a slope of 0 because it had some velocity, it was positives. So wherever I start, I have to have a positive slope. Since I show y1 to be 0, then I start from 0. You will go to some maximum height and keep coming back down, so that at 5 seconds, the y1 is equal to negative 30 meters. And as we found around 1.89 seconds here, it was at maximum height, which was about 17.5 meters. All right, everybody. So to summarize, first, we recognize it was a kinematics equation. There was no air friction, so the acceleration in the y was negative 9.8 meters per second squared always. Since it's constant acceleration, we can use the kinematic equations that will be given to you in the quiz. And then we begin to recognize which variables we knew and which ones we didn't, and just solve for them. And then in graphing, remember the acceleration in the y was constant versus time. Your velocity starting from a positive value, when it got to the highest point, was a 0 velocity, and then keep going negative when it returned down. And then the y, you started from 0, but with a positive slope, eventually made it to a maximum height, and then came back down. All right, I hope that was useful.